Hey everyone, Patrick CK here. In my last video, we took a deep dive into the Creality Ender 3 V3 SE. From unboxing and setup to the first print and some solid first impressions. But as I mentioned then, there was one thing that really stood out while testing those first prints. The spool wobble. Seriously, during fast moves, it was like watching a blender on top of the printer. All that rattling and those sympathetic vibrations feeding back into the frame, definitely not helping print quality. So today's video is all about how I tackled that problem with a super simple, custom, one-piece spool holder mod. No screws, no tools, no more crazy shaking. After that, I'll go over a second design where I tried using magnetic levitation to hold up the spool that almost worked, but didn't. Still, it was a fun experiment, and I'm curious to see if anyone else can run with the idea. But first, let's start with the one that actually worked. Instead of mounting the spool on top of the printer, where it gets violently shaken during fast movements, this design puts the spool off to the side in a clean and stable way. It uses the printer's own weight to hold it in place. There's no screws, no bolts, it just slides around one of the rubber feet underneath and stays put. It's a super simple design with some key features that help this spool holder work so well with the Ender V3. On top, there's a subtle inward V shape that keeps the spool centered and continues to self-center during printing. It also makes mounting and unmounting spools as easy as it gets. No screwing on and off clamps or trying to align with cones or bearings like other mods. That being said, I will advise to mount the spool so that it feeds over instead of under, which I'm sure will trigger some people. The overall thickness of the design gives it plenty of rigidity too. It doesn't flex or sag, even when holding a full 1 kilogram spool. And I was able to print mine with just a 20% infill, so it's efficient without sacrificing strength. Lastly, the beveled lip on the top edge lets the spool spin surprisingly freely, even without adding any bearings like I used in a previous mod. Now, one thing to know is that this model is big. On its longest side, it measures in at just over 200 millimeters, which means it barely fits on the Ender SE's bed. Because of that, you won't be able to use a brim or skirt. You'll need to print it as is, without an adhesion layer. That said, I've printed a few versions of this mod, and adhesion was only ever a problem when I forgot to run the bed leveling beforehand. A few people mentioned adhesion issues in the comments of my first video. So here's what I found. Running the bed leveling before each print makes a huge difference, especially if you've unplugged the printer since you last printed. It definitely seems to lose the calibration results when powered off. So yeah, spend that extra 2 minutes. It's worth it. Installing the mod is as simple as it gets. You just slide the holder under the back right corner of the printer, and it stays firmly in place on its own thanks to the hook that grips around one of the rubber feet and the weight of the printer itself. Also keep in mind that this design is custom made specifically for the Ender 3 V3 SE, so it may need customization to fit properly on other printers. But I feel the design concept can be adapted quickly to almost any printer. The whole reason I wanted to move the spool to the side in the first place was actually inspired by my other printer, the Monoprice MP10 Mini. That printer comes stock with a side-mounted spool holder, which I always thought was a cleaner, more stable, and more compact setup. The difference is that on the MP10, the filament feeds through a built-in tube that guides it from the side all the way to the printhead. The Ender 3 doesn't have that, so I needed a new solution, and that's where this filament guide comes in. To make the side-mounted spool work smoothly, I designed a small guide that clips onto the edge of the top gantry. Its job is to route the filament around the frame cleanly so it doesn't scrape, snag, or get tugged awkwardly on its way to the extruder. The angle of the guide arm was specifically designed to help the spool unwind evenly and straight. Without the guide, the spool can get pulled to one side, which may cause feeding issues. What's really nice is that the guide simply snaps into place with a lip underneath the frame and two studs on top that fit into the existing bolts holding the gantry together. Just like the spool holder, you don't need any tools or replacement screws, and the snap itself, when it slots into place, is so satisfying. It's a snug fit, it's not going anywhere. I did make two versions of the guide. One has a simple loop on the arm where all you have to do is just slide the filament into the opening on top and it's good to go. But if you're looking for ultra smooth filament mobility, then the other version is for you and features a barbed clip to securely slide on a U-groove bearing and also includes a guard to keep the filament in place. To install the bearing, pinch the clip and slide on the bearing, then push the filament under the guard until it sits in the groove of the bearing and you're done. I love the tolerances of this thing. Just enough room for the bearing to spin freely while keeping the filament from sliding out. It's a beautiful thing. Link to the bearing I used will be in the description. One word of note, make sure the guide is completely cooled down before attempting to snap it in place. I learned that from experience. This model is a little more complicated of a print because of the overhangs. You will need to include supports. I ended up using the default tree support settings in Cura 5.9, and it turned out great for me. It's also printed upside down to make things a little bit easier. So with these two mods, the side-mounted spool holder and the clip-on filament guide, the whole setup becomes clean and extremely stable. It honestly made a huge difference for me. The printer looks better, runs smoother, and I don't get nervous watching the spool shake like it's about to launch off the frame. Here's a side-by-side comparison. With the side mount, it's rock solid compared to the top mount. No more excessive wobbling. I think one feature of the setup that aids to the added stability is that there's a lot more slack in the filament, so that when the extruder does move around, especially in quick bursts, it's not constantly yanking on the spool and making it wobble more violently. I'll have the STL files for the spool holder and both versions of the guide linked in the description. So feel free to print them, remix them, or improve on them if you have any ideas. I'd love to see what you come up with. I'm honestly really happy with how this turned out. It's clean, simple, and it just works. Coming up with the idea and iterating through different versions is exactly what makes 3D printing so much fun for me. Alright, now let's talk about something that's a little more experimental. So like any self-respecting man-child, I love magnets. And I had this wild idea, what if I could isolate the spool from vibrations using magnets? Magnetic levitation style smooth. The idea was to let the spool float above a base with as little resistance as possible, dampening vibrations and reducing the drag on the feeder motor. And yeah, in static position, it totally worked. The spool would levitate perfectly, balanced, stable, and kind of magical. But the moment the print started and the extruder began to pull filament, the whole system got thrown off balance. The sudden tugs from the feeder motor shifted the spool just enough to break the delicate levitation, causing it to lean or wobble, and unfortunately that was the main deal breaker. Even with larger bearings and stronger magnets, I couldn't get consistent stability once the print was in motion. I tried a bunch of different designs, from crude prototypes to multi-axial magnet builds with adjustable heights and different bearings, and honestly, some of them looked really cool and did work well when idle, but functionally, they just couldn't handle the dynamic movement of a live print. Still, it was a fun deep dive into engineering for someone who's definitely not an engineer, and I learned a ton along the way, with several boxes of magnets that I can now use for something else. If any of you out there want to take a stab at improving the magnet levitation designs, please do. I know some of you are way smarter and probably way more patient than I am. I'll be uploading all the versions I tried, so feel free to remix, upgrade, or completely reinvent them. Just tag me if you come up with something cool. I'd love to see it in action. Let me know in the comments if you want a deep dive on the magnetic version and why it didn't work, or if you'd rather see the next upgrade I'm planning for the V3 SE. That's it for this video. If you found it helpful, hit the like button and subscribe for more mods, prints, and fixes. This has been Patrick CK. Until next time, goodbye.